Hello again. This is a math video for lesson 18 in module 4, 5th grade Eureka math. Gonna be great. We are doing what we did in lesson 17, but more in depth, and we're adding this unit form to our multi-digit multiplication. If it's been a while, which it has been in this program, since you've done multi-digit multiplication, I would suggest brushing up with some math games. I know Mr. Nussbaum's website is really great. There's a thing called Multiplication Pal. It's an online multiplication simulation. It'll coach you through where the numbers go and why. Play that before you get started with this for a nice warm-up. Anyhow, with our notes for today, it just kind of highlights what the steps are that we're going to be doing. We're going to take decimal multiplication problems, turn them into unit form multiplication problems, use the standard algorithm to label everything in unit form, and then put it back into standard form for your final answer. In the fraction making, we still do have to do this in this lesson. It's really just to kind of wrap your head around what these numbers look like in fraction form so that you can put the proper decimal placement in. Tenths times tenths would be hundredths, etc. So a few sample problems here. Again, pause the video if you need a few minutes to kind of write these things down and make sure you're understanding the concept. A tip here is always put the largest number of digits on the top and then the smaller number of digits on the bottom. I've had students flip them around and then they have 3 rows of partial products. It's a hassle and you're going to make a lot of mistakes probably. So the strategy is to have more digits on top, fewer digits on the bottom. That way you will have fewer rows of partial products as you solve the problem. So you're taking this 421 hundredths times 32 tenths, and then we're labeling with unit form using the standard algorithm. Don't forget that the second row is always the tens place, like this is 30, okay, 32. That's why we're just using the 3 here, but in the tens place. So, so anyway, then you put your partial products in, add everything up. Now the labeling here is what's going to be really key to get the decimal in the right place. Hundredths times tenths will give you thousandths, and therefore your answer in standard form will have 3 digits to the right of the decimal. Couple more problems here before we get to lesson 19. No peeking. 2 and 6 tenths times 4 tenths. Again, take the decimal out, label it with your unit form place value position. Solve it without considering where the decimal is until you finally get your unit form, and then put the decimal where it belongs. Same thing here, but now instead of single digits we have double, and we're going to have 2 and 3 digit problems. And so partial products here, hundredths times tenths make thousandths. Thousandths is your unit form, thousandths is your standard form. I have an additional set of problems. So this is kind of connecting to back in the old days when I was learning how to multiply multi-digit problems with lots of decimals. So this is probably how your parents were taught how to multiply. So what's the deal here? Well, if you have 2 factors with decimals in them, okay? And a lot of kids are like, oh, well, I can just line up the decimals. And no, no, no. I can't say no enough. We are not lining up the decimals. We do line up the decimals when adding and subtracting with decimals, but not when multiplying. When multiplying, we are multiplying hundredths here times tenths, and hundredths times tenths make thousandths. So what is the connection between what your parents know and what you're learning in Common Core? Your parents will say, all you have to do is count the number of digits to the right of the decimal and put the same or matching amount in your answer. That's true, okay? It's true. Your parents might not know why you do that, but that is exactly true. So if you have 1, 2, 3 places to the right of the decimal in all your factors up here, you will have 1, 2, 3 places to the right in your answer. And that is as simple as I can make this lesson. For this one, notice that I am not putting decimals in here in the middle, partial products. Ignore that, okay? But do count up 1, 2, 3, 4 places to the right total in both factors. Therefore, 1, 2, 3, 4 places in my answer to the right of the decimal. That's all there is to it. If you want to know why, it's because of what we're doing today in our lesson. So let's get into the book. Lesson 18, page 231 in my book. Hopefully it is close to that in yours. We're going to multiply using both fraction form and unit form with these lovely words. Okay, and again, we're taking Common Core and we're making a lot of work for ourselves so that you will understand what's happening. You're going to check your answer by counting the decimal places, and this is the old way, and that's why you can do that. It's because we're using unit form, and now you should be able to explain that to your parents. First one's done for you, thankfully. Whole lot of stuff going on here. We're going to transfer it over here step by step. We have our decimal multiplication problem, which then needs to be written in fractions. 23 tenths, 18 tenths, 23 tenths times 9 tenths. Okay, so now you have your fraction, and we do have our problem set up, our 23 tenths times 9 tenths. We'll get to that in just a second, but we also have to rewrite. Remember how redundant this is? Yep, we're still rewriting things. Don't solve the 23 times 9 until you use the standard algorithm here, but you can solve your 10 times 10 for 100. Now that we have nothing else to do but solve what this is, we're going to use the standard algorithm. 9 times 3, 27. Carry the 2. 9 times 2, 18. Plus 2, 20. And also, you must label your unit form labeling. And so if it's tenths times tenths, my label should be hundredths. Don't forget the THS. That really is very, very important. It's critical. Okay, so now we have our 207 hundredths. So what do we do next? We're going to take our answer that we know, which is 207, put it over our what's going to become the decimal value. Now we're going to turn it into a decimal. So if it's 207 hundredths, where do the digits fall? That's the question you're trying to answer. So decimal, tenths, hundredths. If you need to, this is what I call the fill-in-the-blank method. Set up your place value positions, put a decimal in, and then fill in the blanks. Okay? We have to have the 7 in the hundredths place, which is here. So back it out so that you have 207 all in a row, and they're all in the proper places. 207 hundredths, 2.07. So this is your answer in standard form. You want to make sure that these two are the same, okay, that they match, just like those. Okay, let's do the next couple. Here we go. So first make fractions out of your decimals. 66 tenths times 28 tenths. And you can set up your standard algorithm. 66 tenths and 28 tenths. Lots of writing today, so sorry about that. And then set it up again because we're going to multiply just like we do up here. 66 times 28. We know it's 10 times 10, so go ahead and just put the answer is 100. And now we have nothing else to do but the standard algorithm. Here we have a double digit, so instead of like this one with just single, we have to use partial products. So it's 8 times 6, which is 48, carry the 4. 8 times 6, 48, 49, 50, 51, 52. Don't label and don't put any decimals. Move on to the 2 tens. Hold this spot with a 0. 2 times 6 is 12, carry the 1. That's a 1 now. 2 times 6 is 12 plus 1 is 13. Add, 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 add. Now label. Tenths times tenths, hundredths. Okay. Now it comes time to write your, oh, actually, we're not there yet. We need to put the 1848 hundredths. Now it comes time to write our answer in standard form with the decimal. So I need to finish in the hundredths place. Fill in the blanks. Even if you are not quite sure, what if you just put in a whole bunch of blanks? Okay. Find where your hundredths place is. It's the second one to the right. That's where the last digit will go. Now back it out so that everything is in its proper place. Okay? Your final answer will be 18.48, 18.48, and again, you want to read it correctly because 18 and 48 hundredths is what we're trying to learn how to read. Okay, so 18.48 is 18 and 48 hundredths. If you read them properly, it will really, really help you. Okay, next one, 33 tenths times 14 tenths. Set it up over here, 33, use the unit form, 14, unit form, standard algorithm, set it up all nice and pretty, 33 times 14 over 100, nothing else to do but solve. 4 times 3, 12, 12, and 1 is 13. Hold this spot with a 0. Okay, I'm done with the ones. 1 times 3, 3, 1 times 3, 3. Add them up. 2 comes down, 3 and 3 is 6, 3 and 1 is 4. Label. Don't put decimals in here and don't label these. We only label the answer. Tenths times tenths is hundredths. Now we need to write our answer, 462 hundredths. And now we can put this into our standard form location. So 462 hundredths, again, if you're not quite sure where everything goes, think about the place value position. The 2 is in the hundredths place, so the 462 would be in this order. So it's really 4.62 for 462 hundredths. Okay, now I gotta move my book up. All right, let's straighten you out a little bit. Okay, now the directions are mostly or exactly the same. Fraction, yes, directions are still the same. Multiply, fraction form, unit form, counting decimal places. So we're just, counting decimal places. We didn't actually do that up above. 1 here, that makes a total of 2. 1 here, that makes a total of 2. 1 here, that makes a total of 2. Etc. Okay, back onto 2A, and it looks like it's completely done for us. So we're going to copy the same format and use all the same things. Bigger problems though. Now we have numbers in the hundredths. 238 hundredths times 18 tenths, 237 hundredths, and times 9 tenths. Okay. Copy and rewrite so that everything is so redundant because it makes somebody happy. 100 times 10 is 1,000. Go ahead and put your answer for that one. And now there's nothing left for us to do but solve this using the standard algorithm. 9 times 7, 63. 27, 28, 29, 30, and then the other 3 would be 33. And then we have 18, 19, 20, 21. There's only a single digit, so there's no second partial product. But thinking about the label, hundredths times tenths makes thousandths. I'm going to abbreviate THS. Put the root, and then, I know you can probably hardly see that, put the root there, and then put THS so you get the right label. Now, take your answer, 2133 over 1,000, which is what we need here, and then we need our final answer, which is the decimal form. Now be careful. If I have thousandths, okay, so tenths, hundredths, thousandths, I have 4 digits in my number here, so 2133, it has to end in the thousandths place. So fill in the blank. If you aren't sure how to write these, just put a decimal and then a bunch of places to the right and a bunch of places to the left and fill in once you figure out where that place is that you need to have your last digit. The 3 in the last place value position has to be in that spot. 2.133. Answer. It is a 3. Okay. Let's do another one. Oh, look, they gave us what, an inch here to do all this work? That's so kind. Okay, 606 hundredths, because it has 2 place value positions here, tenths, hundredths, times 28 tenths. How do I know it's tenths? Because it ends in the tenths place. Set up your standard algorithm. Go up here where there's lots of room. 606, don't put decimals in, times 28. Now let's label them. It's hundredths, just abbreviate THS, times tenths. This one you can write out, tenths. Okay, set this up. So it's 606 times 28. Solve the bottom. We know it's going to be in the thousandths place. Now there's nothing left for us to do but solve. 6 times 8 is 48. 8 goes down, the 4 goes up. But when 8 times 0 is 0, the 4 just comes right down. If ever you're multiplying with a 0 next, you can just put the answer. 6 times 8, 48. Hold the spot with a 0. 2 times 6 is 12. Carries the 1, and oh, it comes down because 2 times 0 is 0 plus 1 is 1. 2 times 6, 12. Don't put decimals in and don't label. Just add our partial products. 6, 9, 6, 1. Now label. Hundredths times tenths. We know it's going to be thousandths. There it is. Thousand THS. Now how is that going to look? First of all, we're going to do 1,6,9,6,8 over 1,000. Squeeze it in there somehow. And now for our standard form answer, we have to get 3 places to the right. Okay, but I have lots of digits here. So back them out this way. I have 16968. It has to stop here. 16968. So it's really 16.968 in our standard form. Okay, let's do another one. I know you guys are getting the hang of this. Okay, now this one, I know when I said put the one with more digits on top, when you do the standard algorithm, you can still put 0.14 for the standard algorithm, but when you set it up, it's really just going to be 14 hundredths. So let's set it up with our 33 tenths times 14 hundredths. So you can see the fraction I'm talking about. And now you see that we really just have 33 and 14. So in any order, 33 times 14, or if you flip it over and do 14 times 33, that's fine. But I'm short on space, so I'm going to do it this way. 4 times 3, 12. Then 12 plus 1 is 13. Hold this spot with the 0. Oh, and I didn't even label. I'll get there. Hold this spot with a 0. 1 times 3 is 3. 1 times 3 is 3. And then we add here. Now let me kind of go back because we are doing this out of order. 33 times 14 over 1,000. Label your places. It's 33 tenths and 14 hundredths. THS. Now we have our partial products, so you can add them. 462, it's going to be thousandths. THS. 462 thousandths. And now we have our answer, 462 over 1,000. And now we can write it in standard form. Okay, again, where is the thousandths place? It's 3 positions to the right. So now I only have a 3-digit number, 462. Hold the ones place with a 0, and you have your final answer in standard form, just like that. Okay, wow, it's a lot of work. I know this is kind of a bear. This lesson is a big guy. Okay, now on this one, we're going to solve using the standard algorithm. Show your thinking about the units of your product units, and then the first one's done for you. Oh, goody, we can just copy. So 3.2 times 0.6, 32 tenths times 6 tenths equals how many hundredths? Well, they solved it for us here. So you can see that tenths times tenths is hundredths. Here's our fraction. Here's our fraction. Here's how they set it up. We don't really have to do much else. So 32 tenths, 12 tenths. Use the standard algorithm. Now it's a 2 by 2. So 2 by 2 meaning 2 digits times 2 digits. 2 times 2 is 4. Oh, there go the lights. But not all the lights. And we're still going. 2 times 2 is 4. 2 times 3 is 6. And this one's done. So you go down to the second partial product, which would be the tens place. 1 times 2, hold that spot with a 0. 1 times 2 is 2. 1 times 3 is 3. So you should always start the tens under the tens. Now you can add, and label. Tenths times tenths is hundredths. And let's set up our fractions. 32 tenths times 12 tenths. Copy 32 times 12. Put that over 100. Now we know what place value position it's going to be. And so we know that 32 times 12 is 384 hundredths. Therefore, 3.84 is going to end up with the 4 in the hundredths position. 3.84. There you go. Let's do another one. Okay, it's a 3 by 2. So I'm going to use this space for my standard algorithm. It has a little bit more. I'll put my fractions over here. 831 hundredths, because it's tenths hundredths, times 24 tenths. So I have 831 times 24. 100 times 10 is 1,000. Kind of like what we did before. Now we have the standard algorithm. Label with unit form, not with the decimals. So here's our hundredths, and here's our tenths. And start multiplying with the standard algorithm. 4 times 1, 4. 4 times 3, 12. And then 32 plus 1 is 33. Next, don't label and don't put any decimals in. We're here, hold this spot. For the ones place, we're here in the tens. 2 times 1 is 2. Then 2 times 3 is 6. And 2 times 8 is 16. Use your finger to follow across your own work. And please try to keep it neat. It's kind of a struggle. I know for 5th graders, it's really hard. 4. Now we just add. Add down 4, 6, 7, 8, 9. 9 again, and 1 comes down. Now label. Hundredths times tenths is thousandths, THS. I'm abbreviating again. That's not how you spell it. I'm just putting a period there and there. And so now we have our standard form. We know that this is the answer. It's like 19944 over 1,000. And so that's going to be 3 places to the right for thousandths, but I have 1, 2, 3, 4, 5 digits. So you're going to have to back it out all the way over here to fit the 19944. Up here, 19.944. Okay, one more big problem. 750 hundredths times 35 tenths. Set it up on the top, solve the bottom. Now the standard algorithm, 750 hundredths, THS. Now could I just put 75 tenths? Yes, I could, but I'm going to, for consistency's sake, leave that there. Times 35 tenths. Okay, multiply using the standard algorithm. 5 times 0, 0. 5 times 5, 25. 35 plus 2 is 37. Hold this spot with a 0, done there. Use 3 times 0, 0. 3 times 5, 15. Carry the 1. 21 plus 1, 22. Add them up. 0, 5, 12. 3 and 3 is 6 and 2. And then label hundredths times tenths, thousand, THS. So what do I have? I have 26250 over 1,000 for my answer to this. And then for my standard form, I have to end up in the thousandths. That's 3 places, but I have a 5-digit answer, so back it out. 26250 thousandths. 26.250. There we go. Take a breath. Okay. Couple of word problems. They're really not that bad. We will get through this. Oh, click subscribe. Come back again, please. These are fun. Yes, you're getting better. You're getting better at math. Let's do this. Carolyn buys 1 2/10 pounds of chicken breast. If each 1 pound costs $3.70 and she buys 1.2, how much will she pay for the chicken breast? So we're going to multiply the $3.70 times 1.2 pounds. Okay, we're going to use the standard algorithm, but we're going to remove the decimals, and then we'll label it with uniform. We'll put it back in. We don't have to do all the fraction stuff here. We're just going to use the standard algorithm. So 370 hundredths, and then 12 tenths. Multiply with the standard algorithm. 2 times 0 is 0. 2 times 7, 14. This is 6 plus 1 is 7. Hold this spot with a 0 for the second partial product. 1 times 0, get another 0. 1 times 7, 7. 1 times 3, 3. Add your partial products. 0, 4, 14. And then 3 and 1 is 4. Label hundredths times tenths is thousandths. And then write your answer in standard form. And again, this is where your parents would say, okay, well, it's 2 places here and 1 here, so you should have 3. And of course, 1, 2, 3, that would show us 4.44. This is money, so label it. She'll pay. Oh, that's my daughter calling. She'll pay. I'll have to ignore that for just a minute. Don't tell her I said I'm ignoring. She'll pay $4.44 for the chicken breast. We're almost done. There we go. Okay. Now, this last one's kind of a doozy, so hang in there. A kitchen measures 3 7/5 meters by 4 2/10 meters. Find the area of the kitchen. Okay, we haven't done a whole lot of area, but I want you to know that area equals length times the width. Okay, when they say by, that's like saying multiplied. So if we have 3.75, or 3 7/5 times 4 2/10, it's just the standard algorithm. Now let's say we don't do our fancy labeling and we do the old way, 3.75 times 4.2. Look at me writing the decimals in. It's crazy here. Okay, I'm going to have 2 partial products, but we're going to ignore the decimals. 2 times 5 is 10. 2 times 7 is 14 plus 1 is 15. Then 6 plus 1 is 7. We're done with the 2, so hold that spot with a 0. Move over. 4 times 5 is 20. Then I have 28, 29, 30. Carry the 3. 12 plus 3, 15. Add the partial products together and count the places. 1, 2, 3. 1, 2, 3. This is your answer. Now I can sit here and do the 375 and do the hundredths, and I can do the 42 tenths, and I can carry this all out, and I'm going to label it thousandths, and I would end up with 3 places anyway because it's tenths, hundredths, thousandths. So that's what we have to do here, and the proper labeling is the area is 15.75. Now here's a fancy thing that you don't know yet. Meters, M, and then squared. I know, they're just throwing all kinds of fun stuff. Just put a 2 exponent up there. That's how you write area. Last bit. We can do it. The area of the living room is 1.5 times that of the kitchen. So if this is the area of the kitchen and we need 1.5 times that for the living room, LR, we're going to take our 15.75 and we're going to multiply it by 1.5. Now, what is 1.5? In a decimal, or in a fraction first, it would be 1 5/10. So in a decimal, it's 1.5. Okay, super important to follow that. 1.5. Again, standard algorithm right here to find the area of the living room. 5 times 5, 25. We have 35, 36, 37. 25, 26, 27, 28. 5 times 1 is 5 plus 2 is 7. Next row, put the 0. 1 times 5, 5. 1 times 7, 7. 1 times 5, 5. 1 times 7, 7. Add up your partial products. 12. 8 and 8 is 16. 7 and 5 is 12 plus 1 is 13. Carry, and you get 8, 3, 6, 2, 5. Where do I put the decimals? This is your test, children. This is the test. 1, 2, 3. 1, 2, 3. Make sure you have, when it's hundredths times tenths, make sure you have thousandths. So this is the meters squared of the living room. But the final question is find the total area of the living room and the kitchen. It's like they're just mean at this point. 15.75 meters plus 83.625 meters. What now? OMG, we don't have a number here. That's okay. It's in the thousandths place all by itself. Add the rest. Keep the place value positions lined up. 5 and 2 is 7. 13. We are so close here. 8, 9, 9. meters squared for both rooms. Okay, how do we do? Looking back, okay, and I'm checking 15.75, 1.5, just checking, 23, 20, 20. Did I do something wrong? Oh dear, we're at the end. Did I do something wrong? 5, 12, 78, 7. Oh, that's not a 7. OMG. Okay, this is a 1. And look at me. Okay, I'm fixing. Okay, back down to here. So we're going to fix this. So sorry, OMG. Okay. The 25 and the 35, 37 and 25, 28 and 5, 6, 7. That one's fine. But this one here, it's just the 1. It's not a 7. Okay, that's where the error is. We've got our 5 and the 7 and the 5. And this is supposed to be a 1. Look at that. Good thing I took a quick look back. So we have a 1, but that has to carry. So 12, 13, and that's 2. 23.625. 23.625. And everything else should be fine, but this is 39. Heaven help me. It must be late. And it is. Okay, anyway, this is all done. Now you're done. You can relax, turn your work in. Huzzah! I hope this was helpful, and I will see you on the next video. Bye for now.